Okay, Algebra 2, 1.7. We are arithmetic with rational expressions. Rational just means that they're going to be fractions. Being that it's Algebra 2, our fractions are a little bit uglier, but we kind of treat them all the same. Rules all apply, just like they did before. All right, so I've got to reduce it. I've got 6a to the second, r to the fourth, over 2a r to the third. I've got to reduce that just like I would any other fraction. I'm going to do it as much as I can right here. I'm going to treat them separately. So I'm looking at the coefficients first. 6 over 2. Well, 6 over 2 is just going to become a 3, right? A to the second over a, that one's going to cancel. I'm going to take 1 because that was an understood exponent of 1 on the bottom. That's going to become a. R to the fourth over r to the third, that's going to cancel. I'm going to subtract it from the top, becomes r. Now, I'm not quite done yet, even though everything in the bottom canceled. There's one rule that I have to remember. The denominator cannot be equal to 0 because it'll be undefined, okay? So every variable that we removed that is no longer there cannot have equaled 0 to start with. We knew before we started that a cannot be 0 because it would make that whole denominator 0. That r cannot be 0 because that would make it. So I'm not done. I have to write where a and r are not equal to 0. If I don't put that, I haven't finished my answer. All right. Number 10 looks a little bit different. We've got a quadratic. How do I know it's quadratic? Because the degree is 2 on both of them. The red flag that needs to be going off when we see that is that we have to factor. So I'm going to have something times something over something times something. All right, we've talked about this. The first two terms are going to multiply to equal h squared, so that's got to be h and h. Next thing I'm looking at is this sign right here. Because it's a negative, I know that they're going to be opposite of each other. One's going to be plus, one's going to be a minus. Now I need two numbers that multiply together to equal negative 36 and add together to equal negative 5. So the factors of 36 are, we could do 6 and 6, but that's not going to get us there. We could do 9 and 4. I know I'm looking for 5. The difference between 9 and 4 is 5. All right, so 9 times 4 is 36. Negative 9, it's got to be a negative 9 because this is minus. So my bigger has to go with a negative. This pen's not writing very good. 9 and 4. Okay, on my bottom I'm going to have h and h again. My sign is a plus right here. So I know that my signs are going to be the same, and they're going to be whenever this one is. So it's going to be plus and plus. Okay, now I need two numbers that multiply together to equal 20 and add together to equal 9. That one's pretty easy, 5 times 4. All right, so now I'm going to look, is there anything on top that's in common with anything on bottom? Yes. That and that will cancel, leaving me with h minus 9 over h plus 5. Now, just like before, since I had cancellation on the bottom, I need to find out what number h cannot be. Well, I know negative 4 plus 4 is 0, so I know h cannot equal negative 4. All right. Number 20, I'm now multiplying two rational numbers. When we multiply fractions, we know that we can reduce anything on top of either one with anything on bottom of the other side. So we'll go red. I see that 5 and 5 will cancel. I see that 8 divided by 8 is 1. 16 divided by 8 is 2. I see that this A and this A will cancel. I see that this y squared over y cubed, I'm going to subtract 1 from this, and that will cancel. I see b to the first power and b to the third power, so I'm going to subtract 1 from here. That will cancel. I see I have a z to the 8th and a z to the 9th, so I'm going to subtract 8 from that one, and that will cancel. And I have nothing else in common. I've only got an m on top, no m's on bottom. So now I'm going to simplify all this, put it all together. The top is just going to be m to the 12th. The bottom is going to be 2. I've got a b squared. So that one's done. I've got a p squared. That one's done. I've got a z to the, or a y to the 3 minus 1, so y squared. And I've got a z to the 9 minus 8 is just z. Alright, so the only thing that was completely canceled on the bottom is the a, which means that in my solution I have to write a cannot be equal to 0. All right. Number 26, we've got a little more work to do here. I've got, the first thing that needs to jump out is I've got a 4th degree, a 3rd degree, a 4th degree, or a 3rd degree and a 4th degree. I cannot get rid of anything until I've completely factored this. I can't do anything on, I can't take away a cubed and a cubed because I've got to think about it as this is a quantity, this is a quantity, quantity, and quantity. There's not a lot we can do with a 4th degree polynomial, so we've got to figure out some of those things we've learned. How can we get that down to quadratic? Our goal is always to get it to quadratic. What I see in this top term is that I have a common factor, a to the 4th, a to the 3rd, a to the 2nd. I'm going to pull an a, if this thing doesn't want to write, a to the 2nd out, and I'm going to be left with a squared plus 6a plus 5. On my denominator over here, I see I have an a in all of them, so I'm going to pull an a out. And I'll be left with a squared plus 7a plus 10. On the next numerator, I see I have a common factor of a. Will leave me with a squared plus 10a plus 16. And on the bottom, I see I have a common factor of a squared again. And I will be left with a squared plus 9a plus 8. All right, so now I have quadratics. Red flag tells me I need to factor quadratics, but just to, I like small stuff better than big stuff. I'm going to go ahead and cancel out a squared with a squared, a with a. That's less that I have to keep up with. All right. So now I need to factor everything. All right. Now on this step I just did, because I canceled out a on bottom, I know on that step a cannot be equal to 0. I need to keep up with that as I go so I don't forget it. All right, so a squared plus 6a plus 5 is going to be a and a. My second term is positive, so they're both going to be the same. My first term is positive, so that's what they're going to be, a plus plus. Two numbers that multiply together to equal 5, add together to equal 6 will be 5 and 1. On the bottom, I've got a and a. I need two numbers that multiply to, well, my signs are going to be positive because they're the same, and then whatever the first sign is. Two numbers that multiply to equal 10 and add together to equal 7 is going to be 5 and 2. Over here I've got a and a. My signs are both going to be positive. Two numbers that multiply together to equal 16, add together to equal 10 is going to be 2 and 8. And finally I've got a and a. Two numbers that multiply together to equal, let's see, my sign's going to be plus and plus. So we can see, let's see. Yeah, I made an error here. So if you'll look, you'll see that I said, when I factored this one, I'm glad I make errors on this. I want you to see how they stand out and how I know I made errors and how I can correct them. When I factored that one, I said that I needed two things. Okay, I was just looking at the wrong one. So that's the one I'm working on now. So I have a, and I need something that multiplies together to equal 8 and adds together to equal 9. I was looking at that first term. So I've got 8 and 1. All right, so when I go to cancel, that one and that one goes away. So I just got rid of something on the bottom. So I know that, golly, this thing is not writing. On that one, a cannot equal -1 because -1 plus 1 is 0. All right, this one and this one cancel. So a cannot equal -5. This one and this one cancel. A cannot equal -8. A plus 2 cancels. A cannot equal -2. Alright, so what do we do when everything cancels? Well, the answer is just 1, where a cannot equal -8. negative 5, negative 2, a negative 1, or a 0. All right.